Hi, I'm Tom. I'm the Chief Technology Officer at Ridgeback Network Defense. We're based in Baltimore, Maryland. I've got around 30 years experience in the information security space. Our company makes the Ridgeback Interactive Deception Platform, which gets rid of adversaries in real time. So here's Ridgeback running. I'm going to go ahead and turn off the MAC addresses, make it clear. This is what a normal, healthy, happy network looks like in the network graph viewer. Now this is just one view into Ridgeback. The green IP addresses are live endpoints. These are real nodes. There's some that are hidden here, and I'm going to bring them out real quick. They're amber. These are decoys that have been deployed. The reason decoys get deployed in a healthy, happy network is because this is a DHCP network. So nodes are free, or endpoints, devices, are free to join the network and leave the network. When they join, they claim an IP address and get it. When they leave behind almost like a shadow, and Ridgeback will fill that space with a decoy. So I'm going to hide the decoys for now. So healthy, happy network, good hygiene. It's a star pattern. The gateway's in the center. All the peripheral nodes are on the outside. So this is a subnet. I'm actually going to go forward in time. There's a time slider up here. So there's a little time widget or a filter widget. It's for a number of these displays in Ridgeback. And if I go forward in time, I'm going to look for something interesting that happened over the past 24 hours. So let's see. It's been a while. It's been a while. Too far. So I'm just looking. So what I'm showing here, what I'm demonstrating, is just an example of what things can look like if you let an attack evolve completely and you don't do anything to stop it. So here at this point in time, I see a couple interesting things have happened. These two endpoints have broken away from the main cluster of the gateway. And these two endpoints they have a fan out that dead ends. And if I turn on the decoy host, you see they're actually talking to decoys. So what's actually happening with these two endpoints is they're conducting ARP scans. They're looking for hosts. They're not trying to contact any services. They're just doing a very low-level scan of the network to see what's out there, what can they connect to. Now, if I turn this off, the green nodes are the real live nodes. This is what's really on the network. But if I turn on the decoys, this is what it looks like from an adversary's perspective. So when an adversary goes out and looks for things, if something is not there, Ridgeback will always come back and answer, yes, that's there. So from the perspective of this IP address, .33, on the left, all of these amber IP addresses are real. They really exist, and they're really on the network. Now the reality is that Ridgeback is creating the illusion that these exist. They don't really exist at all. And in fact, Ridgeback does not spin up any additional resources. This is not emulation. There's no additional assets to manage or anything like that. It's only the illusion. So we have two perspectives into the network. We have what's really out there, and that's what the users see, the users that connect to the legitimate resources. And then there's what the adversaries see, the adversaries who are greedy and who are trying to look out and see what they can get into. Keep in mind that an adversary only knows what they can observe. So I'm going to turn off the decoy hosts. I'm going to go forward in time. Something really interesting has just happened here. This node has turned red, this IP address. I'll turn on the decoys, see what it looks like, right? So I turn them off. So this one is turned red. So we call this an active threat. Now these guys that were green before, we call those possible threats. We call them possible threats because they're sending out and contacting decoys using a network protocol that does not carry a payload. So these guys, even if they have malicious intent, they're not actually doing anything bad. They're not harming anyone, but they are gathering reconnaissance. They are collecting information on the network. It's bad. We generally don't want that. This guy is an active threat. He's turned red. He's an active threat because he's contacting decoys and he's using a protocol that carries a payload. In this case, it's TCP. So these numbers on the edges are the port numbers that he's connecting to. So port 7, port 80, and so on. And again, ambers, this is what the adversary sees. This is what the adversary thinks is real. Turn them off. This is what's actually on the network. Now, from the adversary's perspective, he has reached out, connected to a whole host of TCP services, host services, application services. Connections have been established. The TCP three-way handshake has been established. So the kernel in the operating system for this host is actually allocating space and saying that he has active network connections. The reality is there's nobody out there talking to him. There's no real assets out there. There are no connections that have actually been established. They're only in the mind or the CPU of the adversary. Now, a curious thing right here that I'll note is that Ridgeback is not going to emulate anything on these. It's simply going to hold them open, and it will not let the adversary, won't let our threat host disconnect those connections. It will not let it tear those connections down. This may sound simple and basic, but the reality is it causes quite a bit of chaos in the adversary's mind. As the adversary is collecting information in the kernel, it's accumulating a whole bunch of connections. When they try to tear those down, they go into a time wait state. It's just generally very confusing and disruptive for the adversary here. And I'll go forward a little more to show some other things that have evolved. So here we have, we have another ARP scan that's occurred, and over here on the upper left we have another active threat. There is a payload. In this case, these are ICMP messages. Now, this kind of diagram is fairly easy to interpret. You don't have to interpret this, though. We have something called the Incident Explorer, and then we have a whole host of ways to actually integrate other tools with Ridgeback. So if you have a SIM product, for example, you can take the Ridgeback data and send it to the SIM. So there's some interesting things I'd like to note here on this display. One, Ridgeback is displaying who is talking to whom. Okay, so when you plug Ridgeback in, one of the first things that happens is you get situational awareness onto the network, and that's actually kind of a happy side effect. When I made Ridgeback, that wasn't my intent. My intent wasn't, I'm going to make any kind of network surveillance tool. I was trying to make a deception technology, something that would go out and reach out and irritate, attack, and annoy the adversaries. But it turned out that the method that I chose made it very easy to gather data to see who is talking to whom. This is not only good from a security perspective. You can see if things look like they're malicious. For example, some of these things jump out immediately and say that they're threats because they're contacting decoys. But you can also see nodes talking to nodes that shouldn't be. So, for example, there was one instance where someone had a number of endpoints on their network, and as soon as they turned on Ridgeback, they saw that there were cross communications between these nodes. And because they were the network administrator, they knew how their network was supposed to be behaving. And they knew immediately, just from the visualization, that something was amiss because those nodes should not have been talking to each other. And so it turned out that it was some kind of a side channel, a side protocol going on, and they had an incident response and took care of that. But that situational awareness is something really, really cool. Another thing that I'll do, for example, is I will take Ridgeback and I'll load it on a laptop and I'll go to client sites, and all I have to do is connect with a Wi-Fi. So Ridgeback doesn't require any special initialization or configuration, or you don't have to reconfigure the network. You don't have to rig up a spanner mirror port. All you have to do is load Ridgeback on the server and basically just plug it into the switch or the Wi-Fi, whatever it is that's doing the switching for that layer 2 broadcast domain. So I take Ridgeback in, and I've done this on a number of occasions, run it and attach it to a client site, and immediately you can see what's going on in the client network. So that's a real valuable thing that a lot of people don't have. They don't have that instant, situational awareness of what's going on in their network. You might NetFlow and stuff, but maybe you want to just jump into a spot and say, what's going on here? So that's one part. Another part is that Ridgeback will immediately start deploying decoys if necessary on that network segment. So if I take it into a Wi-Fi to a client site, then immediately, if something's going on and someone, let's say a worm is trying to propagate to that network, immediately you're going to see that worm contacting all these decoys. So this screen, the network graph, is just one way to look into the network. This is very useful for a network administrator or someone who is interested in doing a link analysis of who's interested in whom. We have another view called the Incident Explorer. So here's the Incident Explorer. The Incident Explorer takes what you might see in the network graph and distills it down into actionable intelligence. So these are things that must be taken care of immediately. So in Ridgeback, there's not a concept of false positives. Ridgeback is not actually detecting anything. Ridgeback is putting out mousetraps in our kitchen, and it's waiting for somebody to stumble into them, and it puts out a lot of mousetraps. So we have active threats and possible threats. Our active threats are nodes or endpoints or servers, whatever it is on the network, that are connecting to decoys, and they're communicating with them using a protocol that is carrying a payload. So any one of these active threats has the potential for immediately breaching some other node, something else in our network. Possible threats are threats that are contacting decoys, but they're contacting them using protocols that don't carry a payload. In this case, it's ARP messages, ARP, Address Resolution Protocol. So these nodes are actually conducting reconnaissance, surveillance on the network. Still, we do consider them threats, and you should fix them. Now, this display takes, it kind of distills down the philosophy of Ridgeback, which is we're not going to try to look for things. We're not going to try to detect things. We're going to put out landmines, basically, to catch people, to have them stumble into them. And when they do, we're going to take action. We're not going to passively wait for something to happen. We're not going to wait for someone to be breached. I can open up one of these and get a forensics log. So this is a log of the communications that, in this case, the .20 IP address made over time. And the blank entries, the white ones, are normal. But down here we see they've turned red. They've turned red because these communications are going to a decoy. At this point, I will stress again that a decoy is not really an asset. It's not something that gets spun up. A decoy is not it's not an IT asset. It's not something you have to manage. It's merely an illusion. It's Ridgeback watching Ethernet frames go by and then modifying them as needed to give the impression that these things are out there. Ridgeback is kind of like Ridgeback is like an oracle that if you ask it a question, it always says yes. Does IP address 223 exist? Yes. Is port number 443 open? Yes. And then it holds those open. Ridgeback does not communicate back. It'll simply discard any communication sent to it. It doesn't give any indication that anything is going on, anything's wrong. It doesn't give any clues that, hey, I'm an emulated resource like that. And it does not let you close the connection. From an adversary's perspective, it's exceptionally difficult to realize what's going on because they don't have direct observation into the layer 2 where these things are going on. So we've gotten feedback from people that say things like, oh, it looked like my Tor node kept bumping me off and I don't know why. Or my tool kept locking up. It would execute and run. My scan, for example, would start and then it would just freeze and I don't know why. So here we have these things that are actionable. Now also in this display we see two buttons. There's a red button and a green button. The red button will initiate and isolate host countermeasure. The green button will release that countermeasure. It'll stop the countermeasure. So the isolate host countermeasure is a countermeasure in which Ridgeback sends out spoofed messages, spoofed ARP messages that impersonate the IP address that we want to disconnect from the network. So in this case, if there is a .20 IP address and we want that node to be isolated so that it can't do any harm, and that will also effectively lock up all the processes that are trying to do network I/O, they'll freeze, then we initiate an isolate host. Once we're happy that that node has been corrected, that there's no longer a threat on that IP address, we can press the green button to resolve it. And then the isolate host messages will cease. Now, I'm showing the isolate and resolve buttons on this screen. They're manual in this screen, but we actually have a process called the watchdog that runs in the background. The watchdog is watching, in general, things that Ridgeback is doing, things that are happening from the perception of Ridgeback. And we can configure the watchdog to automatically initiate countermeasures or take other actions, like send us an email or send us an SMS or send a message to our firewall, or if we have an SDN, to go out and reconfigure part of the network. The watchdog could, for example, as soon as it sees the illegitimate traffic going to decoys, initiate on its own an isolate host countermeasure for this IP address, isolating this host, and then from the perspective of that host, everything locks up, everything freezes, and then send out an email or an SMS message or whatever it is that we want to do, and then we go in and we fix it. Our incident response team goes and fixes this problem. The possible threats are very similar to the active threats. The key difference here is that these are not sending payloads. So these threats are not actually sending payloads, they're actually just doing reconnaissance. But just like in the active threats, we can isolate them using the user interface here, or we can have the watchdog automatically isolate them, or initiate any other countermeasure that we see fit. Something interesting about the watchdog is that you can look for things that are not only threats, but things that violate your security policy. This is very important from a compliance perspective. If compliance is important to me, and I want to prove to my auditors, for example, that my network is properly configured, that my machines are properly configured, all of my DNS servers are well behaved, that nothing is going astray, nothing is pointing to the wrong thing, I can actually take the policies that articulate my compliance requirements, put them in the watchdog, and then have the watchdog automatically, in real time, take action if anything goes out of compliance. So what's an example? Let's say I have an office, and my office has a number of desktop computers with employees that come in 9 in the morning and they leave in 5 in the afternoon. I can actually, and let's say, for example, they are forbidden, these machines are forbidden from contacting each other. They're only supposed to be talking to the gateway. So I should not have any peer-to-peer clients running. I shouldn't have anyone sending direct messages from one machine to another. So I can actually configure the watchdog to alert me or take other actions when any of these machines violate my policy. If one machine talks to another machine, I could, for example, immediately isolate that machine. Or I could send an email to the auditors or to me or to whomever saying, hey, I'm out of compliance, do something. I could record it somewhere and say, at this time, it went out of compliance. And then later on, record, hey, I'm back in compliance. Or I could simply have a hour-by-hour report or log, for example, that says everything's in compliance, no problems. So that's another way that the watchdog can be used. So I think that's a really important point, because Ridgeback is not just a security tool. Ridgeback can also be used for IT management in general. After something has been isolated and then resolved, it moves from the threat bin down to the resolved threats to note that it's been taken care of. We also have a graphical log explorer. So Ridgeback can accumulate a lot of logs. These logs will go into, there's a flat log file where there's key value pairs. There is, that also gets distilled down into a SQLite database where you have structured data. So I know sometimes people have problems with, I've got these logs, but I don't know how to parse them. What do I do? Well, we also have the logs go into a SQLite database, and we have something called the Ridgeback log adapter that's built into it that facilitates that process. So this is a way that we can graphically look at these logs, so we can say, hey, show me all of the logs, the log entries that went to a simulated destination. And then here they are. And the red in this screen indicates that it's simulated. The data also goes to a SQLite database, so it can be pulled out into some other tool like Splunk or QRadar. Ridgeback can also output to a syslog, so you can have syslog files that can be sent to wherever. You can have it streamed off to Alien Vault if you want to, for example.